LegitTechTutorials, and welcome back to Beginning Arduino. Today we're going to talk about PWM that I talked about a little bit last tutorial. So I'm back into 123D circuits. Make sure you load in a new breadboard circuit, and what we're going to do is we're going to do what we usually do and drop the Arduino Uno in so we get a nice good view of that. Then I'm going to pull this guy down to where we can see what we're doing. Now what we're going to do is remember what we had here with the PWM. The PWM is right here. These are the digital outputs, and here are all our other stuff. The one with the little squiggly lines are the ones that we're going to work with today. So basically what we're going to do is we're going to use all of this stuff to control an external LED just like we did last time. So let's go ahead and set up our LED. So I'm going to go to the top, find our LED, put it across here. Then what we're going to do is grab another resistor again, put it across. This time, let's make it a little brighter. Let's do like, we'll just do the 220 again. But now remember that when we do PWM, you could still only get as bright as if you did a 1 on a digital. So, it's not going to be any brighter. PWM is not going to make it any brighter. Still only 5 volts possible. Okay, so then let's go ahead and wire this up. What we're going to do is we're going to go from a PWM circuit, so something with a squiggly line. Let's do a 9. So we're going to go from 9 to the power side of the LED. Then we're going to go from one of our grounds to the ground bar on the breadboard. Then what we're going to do is we're going to take a look at the code. So let's go ahead and pull up the code. First thing we're going to do is we're going to modify this generic one to have pin 9, because as you see we're in pin 9. Then we're going to set that LED pin as an output, just like we usually do. Now we're going to use this other way of doing an output. So we used to use a digital write, but now we're going to use an analog write. So that uses PWM. Basically what PWM is PWM stands for pulse width modulation. So what pulse width modulation does is it replicates a analog output, right? So basically what it does is you send a digital output, but you send it very quickly. So basically it's like you could control the brightness of a bulb by tricking human eyes to see the bulb as being dimmer. How it does this is it cycles that particular light on and off very, very quickly. So imagine you're in a room with a light and you keep flicking that switch on and off multiple times. It will seem like if you get it fast enough that the light, because light speed is set, that if you cycle it fast enough that it will seem that it is less dim, and you'll see here in a second. But yeah, that's how it does that. Is it cycles it on and off very quickly, and by cycling it on and off very quickly, you can control the power that's being dissipated over it because of how long you leave it open. All right. So let's go ahead and change this. So what we're going to do is change this to analog write. Now analog write takes 2 arguments in C. It takes the pin, which we have LED, which LED is pin 9. Then it takes a value between 0 and 256. 256 is 8-bit in binary. So if you have 8 bits, each one is 2 to the first power, consecutive powers. So 2 to the 8th power is 256. You're going to have to just trust me on that, because that's a binary thing. So what we're going to do is we're going to give it a int value. So let's give it like 128. And then let's not give it a delay. And then let's just see what we got. And I'm going to show you guys some different things that we could do to mess around with this. Okay, so let's go ahead and upload that. So as you see, you can see the brightness there. Do I have a delay? No, I don't. So you could sort of see it emulating that brightness by sending that signal very, very quickly. And technically, in this case, we wouldn't even need a resistor because we're sending that. It's not going to get that same amount of current. Give me one. We're using this resistor just to remain safe. You'll notice that if we also just deleted this, uploaded it, oh, of course we need a line from here to the negative. Huh. I think we need to go into component mode. There we go. So let's go back into component mode and let's add that resistor back, just to be safe. Don't want you guys to be damaging any parts. So just to limit how much we put through there. All right, so let's go ahead and go back to the code editor, upload this one more time. So basically what you're seeing here is that it's half of what is possible for this particular guy here. It's half bright, and you see sort of that emulation there of it getting brighter and dimmer at the same time. Because, you know, with limits on the computer screen, right, it's a little bit different. Let's do full 256. Okay, it says we're on. And you can see here that the system is lagging for some huge reason to try to emulate this 256 analog write. Let's just go back to, let's just do like 250. There we go. So there you go. You can see that it's now brighter. So the computer is having problems emulating that as the calculations. I don't know why. But in real life, it's definitely a lot quicker, and it won't have any problems with this. But like I said, pulse width modulation is how many times it flicks it on and off. So the less time that the higher you give it, the closer you give to 256, which is a full 8-bit, which the Arduino runs on 8-bit, is going to make it off less time compared to it being on. So, and the closer you get it to 0, the more time it's going to be off and the less time it's going to be on. So now with this, you went over 2 different ways of controlling a circuit by either using digital or by using PWM, which is a analog emulation using digital. So also I wanted to do a quick little loop that the book does here, which is pretty cool. Whoops. So this is a quick little emulation here. Make sure I have everything. This is going to be I. error on line 14. I forgot to put there's a comma there. Alright, there we go. So now technically what you should be seeing is that it changes. As you see, it's like the system's really laggy for whatever reason. What you should see is that the light progressively gets brighter. There it goes. See how it's getting brighter? This is a good example of exactly how it works. So PWM, when it's closer to 0, it is off more of the time and on less of the time. And then as it gets closer to 256, which is its full value, it will be on most of the time and off other times. Also, I think I know why it didn't work, is because you can't actually use 256. You can only go up to 255. So if I did 255 here, and I ran that, see now it's working at 255. So 256 will not work. It will only send 255 because 256 is reserved. So yeah, so let me show you guys that emulation one more time of the simple loop I here. So the light gets progressively brighter and brighter the closer it loops to 256. And like I said, it's using PWM and emulation of digital. Alright, so now that you guys have seen this here and the code to run this, you can now control external equipment using either digital controls or pulse width modularization, which is a digital emulation of an analog circuit. Those are the two ways of controlling output, and later on we're going to go over the different ways of taking in input. But we're going to get a lot more practice on this output and do some other fun projects as well. Alright, so it's been Steven from LegitTechTutorials. I'd like to thank you for watching this video. If you like this video, please subscribe for more videos like it in this series and other series as well. If you want to learn more and see all the verbiage, check out the reference book in the description. Very good book, very good price on it. And if you guys have any questions, email me. And I'd like to thank you for watching, and I'll see you guys in my next video. Thanks for watching. Take it easy. Peace.